Building a standard timber floor requires precision. It is the surface you walk, stand, and live on, keeping the building safe and usable. To achieve that, we are going to walk through a straightforward, 6-step construction process. Stick to these steps, and the result is a perfectly flat, level, and strong floor with zero squeaking. Before picking up a hammer, this reference graphic shows a simple framework to organize your build, FTMC. This stands for Functions, Types, Members, and Calculations. You have to know what parts you need and exactly how much material to order. Looking at this guide, we determine the floorboards and exact joists needed for equal spacing. We also calculate their physical depth. As the text points out, deeper joists prevent bending under pressure. Methodical pacing. Running these exact numbers before you begin construction is the only reliable way to avoid wasting expensive materials and to guarantee the floor can safely support people and furniture. Step 1 in our 6-part sequence is measuring the total floor space of the room. You take this physical area measurement and check it directly against those upfront material calculations to ensure you have exactly enough timber on site before you start cutting. Once measured, Step 2 is fixing the wall plates to the foundational walls. Here is the definition for wall plates: lengths of wood placed directly onto foundational walls. Their primary job is providing a resting place for joists, distributing the floor's massive weight evenly across the concrete base. Securing these plates perfectly level creates an unyielding structural baseline. If this lowest layer is crooked, every subsequent layer stacked on top of it will fail. With the baseline set, Step 3 is installing the joists so they rest directly on top of those secured wall plates. This section of the manual defines joists as the long wooden beams placed under the floorboards. They act as the main skeleton of the structure, carrying the actual physical weight of the floor itself. As you lay these beams down, you must space them completely evenly. This requires checking your level constantly across every single beam as you work across the room. This common mistakes checklist shows exactly what happens if you rush this process. Uneven joists or poor spacing directly result in weak support and noisy floors. Sometimes you need to break this even spacing to make room for a staircase. As we see in this section, adjusting the floor structure to leave an open space is called trimming. When you cut standard joists to make that trimmed opening, you lose support. To fix this, you install a specific heavy beam called a header around the opening, which ties the cut joists together and maintains the floor's overall strength. The entire integrity of the floor relies on this grid. Rushing the spacing or failing to support trimmed gaps with a header guarantees a compromised floor. With the main joist skeleton set, Step 4 is adding bridging. Bridging involves taking smaller blocks of wood and wedging them tightly between the long, parallel joists. These blocks act as mechanical braces. They keep the long joists completely steady and prevent them from twisting or moving side to side under the heavy load of foot traffic. Stopping that lateral movement now prevents the joists from rubbing together, which is the primary cause of floor squeaks. These connections force the individual beams to work as a single unit, which prevents the joists from twisting when you walk across them. Step 5 is fixing the floorboards securely across your freshly braced joists. Looking at our component definitions, floorboards are simply the top layer. Laying these horizontal wooden boards down over the joists physically creates the actual walking surface of the room. Finally, Step 6 is finishing the surface. What you add here depends entirely on the room's final purpose. This page outlines 2 common finishing members. If you are laying tile, you install a subfloor base layer to add necessary support. At the bottom of the walls, you install skirting boards to protect the edges and improve the room's final appearance. With the skirting and subfloor in place, the rough framing becomes a finished surface ready for daily use. You have now completed all 6 steps of the construction process. But before the job is officially signed off, we have to perform a final quality check. This checklist shows the exact physical standards a successful build must meet. During a walk test, the floor must be perfectly flat and level, strong and stable, and completely free of squeaking. To hit those targets consistently on future builds, follow the non-negotiable guidelines. Always use strong materials, rigorously check your levels, and tightly secure every single part. And keep the FTMC acronym, functions, types, members, and calculations, readily available to organize your approach. Following this exact sequence of calculation and assembly ensures the floor remains stable and safe for the life of the building.